Good evening, everyone.
Good evening, ma'am.
Evening.
Good evening, ma'am.
Good evening, everyone. Okay. So, did you go through the topic once again of week 10? Have you gone through it again?
Going, ma'am.
Okay. Okay. So today is a doubt session. So I will be taking your doubts. So we will go activity wise. Okay. So for the first, I will ask for the activity one. If you guys have any doubt, then raise your hand. Then we will go move forward with the next activities like that. Fine. Understood?
Hmm.
Okay.
Okay.
Okay, fine. Okay, let's go with the activity 10.1. So please raise your hands if you have any doubts in activity 10.1.
Ma'am.
Hmm.
Ma'am, in 10.1, ma'am, we have dealt with, ma'am, discrete case. And, ma'am, sometimes I got confused in the continuous case. So, ma'am, how to, ma'am, deal with continuous in this field?
Sorry, I could not get you. Can you just say it once again?
Ma'am, my question is 10.2 activity. Question.
No, I'm just asking about activity 10.1. Do you have any doubts in 10.1?
No, ma'am.
Okay. Anybody else? Anyone having any doubts in activity 10.1? If you're not able to speak, just raise your hands. Okay. Okay. So, okay, then I'll move forward. So 10.2,
Ma'am, 5 and 6.
5 and 6. What's your doubt in this?
Ma'am, ma'am, how to get the, ma'am, marginal distribution for S? Ma'am,
Marginal distribution of what?
ma'am, some confusion in this mu.
Yeah, that is what I'm asking. What's your confusion in mu?
Ma'am, my great confusion is that, ma'am, without finding the posterior mode, can we find the posterior mean? And for continuous case, how?
Without the posterior, what can we calculate the posterior mean? You are asking that. But
And
here, posterior mode and posterior mean are two different things, right? They are not connected.
Ma'am, confusion, ma'am, how to do such type of question, ma'am, in continuous case.
Can you please explain? Like, I'm not getting your point. I'm not getting your doubt.
Ma'am, simple, ma'am, how to solve question number 5 and 6.
5 is just, I told you, like, have you attended, did you attend the live open session on Sunday?
Open sessions on Sunday.
Did you?
Yes, yes, ma'am. Done.
Yes, ma'am. You have attended, right? So in that session, I already told you that for the normal distribution, you just have to learn the formula, correct?
Ma'am, that posterior mean formula.
Yeah.
Oh.
Okay. So for the fifth question and the sixth question, you just have to remember that formula. Okay.
Ma'am, that one, that x bar into mu naught
Ha.
sigma naught square by
Yeah.
n into sigma naught square per sigma square.
Yeah, that is what. Like I guess I did one question of that, correct?
Yes, ma'am.
Yeah, we have done a question. Okay, to share my screen. This was the question, right? So for the normal distribution, I already told you, you just have to remember this posterior mean. That's it. And put
Ma'am,
the values.
excuse me, ma'am, will this formula be given in the exam or I have to remember?
I think this won't be given. You have to remember this. Okay.
Yeah, yes,
Deepayan,
ma'am.
you got the question how to do it. You just have to remember put the values in this formula. Okay.
Hmm.
Hmm. Okay. So any other questions from activity 10.2?
Ma'am,
Yes.
ma'am, can we do that in the ma'am form of likelihood into prior?
Which one?
Ma'am, this question. That
This
you are
normal.
showing. Yes, ma'am. Normal.
That will be a lengthy, like the equation, it will be very lengthy. That's why I just told you to just learn the posterior mean formula. The posterior
Okay.
mean formula already came from that equation only, the likelihood into prior only. Okay, but the calculation is very long. That's why I'm like, just remember this posterior mean, because they won't be asking you to solve everything. They are just asking you the posterior mean, right? So just remember the formula, right?
Okay, ma'am. Understood.
Yes. For the normal distribution, just remember the posterior mean. Other than that, for the beta, for the gamma, geometric, and everything, just you can calculate. It's very simple calculation. Okay,
Hmm.
so you can do that, but not for the normal. That's why we are just telling you to just remember this posterior mean formula for the normal, only for the normal case. Okay.
Hmm.
Yeah.
Understood.
Yes. Okay then. So 10.2 activity is clear to everyone. Have you guys solved the activity questions and the practice assignment yet?
Ma'am, only two I have solved, like 10.1 and 10.2 I have solved. I actually
Okay.
did not attend the Sunday class. Yesterday there is TA class. She was
Hmm.
helping, I think her name was Shukanya.
Hmm.
So she helped me understand things, but I have still some doubt in conception.
Hmm.
So I want to ask you that is there a YouTube link available? Like the video you take that class in Sunday, is that available in YouTube?
Yeah, that's available in your calendar
Okay,
only.
okay,
Like under that, the YouTube link is already pasted, right?
okay, got it. It's
Ah,
thank you, ma'am.
yes,
That day means Sunday evening. You discuss the theory also, right?
correct.
Okay, ma'am. We will go through it.
Okay, fine. Okay. So at 10.2 is clear to everyone. Shall I move forward to the next activity then? If you guys have, like, nobody has any doubts. Give me a thumbs up or anything. Just please make it little. Yeah. I need responses from the people. Yeah. Good. Okay. Okay. So any doubts in 10.3?
Ma'am, question
No,
number
ma'am.
1 and 2.
Uh, oh, one by one, please. Deepayan, yeah. You speak.
Ma'am, 1 and 2. Ma'am, slightly confusing, ma'am. This is not because this is not Bernoulli. So, ma'am, how to do that?
One and two.
Hmm.
Let X be a discrete random variable taking values with respective probabilities. Consider the sample from X using the uniform 0, 1 prior. Okay. See, simply it's given. See, X is taking values 0, 1, and 2. Okay. And we have the probabilities with it. These are P by 3. And what is the probability of 1? 1 minus P. And the probability of 2 is
2p
2P
by
by
3.
3. Okay. Now, this P is unknown to us. This P is like the probability. Now, this P is unknown, but we have the information, the prior distribution that P is following is a uniform 0, 1. Correct? Right? Okay. Now, you have to calculate the posterior distribution. So, we know the equation. What is the equation? The posterior is
Proportional to
A
likelihood
theta.
times priority.
likelihood into prior. Correct? Okay. Now, first of all, let's calculate what is my likelihood. What is your likelihood?
It's Bernoulli, right?
Yeah. So we have the samples as well, right? So let's suppose. So here my for 0. Okay. So the probability of 0 is P by 3. Now, how many times my P by 3 is occurring?
6 months.
1, 2, 3, 4. Four
Okay,
times, right?
sorry. Don't have the
How many
question.
times 0 is occurring? Sorry, how
4
many
times.
times 0 is occurring? That is 4 times. Okay, so it's a simple case. So if it's a Bernoulli, okay, I'm having 1, 0, 1, 0, something like this kind of samples. I'm having only 2 numbers, correct? And these 2 numbers are having probabilities like P and one other probabilities like 1 minus P. So how do we calculate the likelihood? It's like P raised the how many times the 1 occurs and 1 minus P raised to the power the total minus X, correct? This is the way we write it, correct?
Yes, ma'am.
Similarly, we have three numbers here, 0, 1, and 2. Okay. Now, it's the same thing. How many times 0 is occurring? That probability raised to the power, correct. Similarly, my 1 is occurring how many times?
3 times.
Sorry?
3.
3 times. Okay. So, this will be 3. Then again, how many times 2 is occurring?
3 times.
It is also 3 times. Okay. So, this is my likelihood. Okay. Now, what is my prior?
It's just 1.
Ma'am, 1.
It will be
One.
1. Okay, which is 1 minus B minus A, right? Which is 1 minus 0, which is 1. So just you have to put this value here. So posterior will be proportional to P by 3 raised to the power 4, 1 minus P raised to the power 3, and 2P by 3 raised to the power 3. Now, if you see, there is a proportionality constant. So these constant 3, 2, and 3, we can take it out, like we can ignore this. So we are left with P raised to the power 7 and 1 minus P raised to the power 3. Correct?
Yes.
Okay.
Ma'am?
Now you tell me which, yes?
Ma'am, what is the purpose of ignoring 2 and 3?
Okay. Just like in general, if let's suppose A is proportional to B. Okay.
Yes,
So if I have to remove this proportionality sign, what I will be adding? I will be adding some constant K
yes, ma'am.
into B, right? Similarly, in
yes.
this question, if you see this P, this 3, so constant term is like 2 by 3 raised to the power 3 into 1 by 3 raised to the power 4. Correct? This is my constant term. One constant term, let's suppose K. Okay?
Yes, ma'am.
Yeah. So now there is a proportionality sign here. So this constant K, I can ignore it because there is a proportionality. If there is no proportionality, then we will consider this constant term.
Okay,
Got
ma'am,
it?
understood.
Huh. Now, tell me which distribution it is.
Yes,
Ma'am,
beta 8,
This
comma
is
5.
beta.
8, comma 4. Sorry.
This is 8, comma 4.
4.
4.
Is this the answer? beta 8 comma.
Yes,
Correct.
ma'am.
Okay.
Ma'am,
Now, yes.
in the second question, it will be just the average of the beta, that is 4 by 8 plus 4.
Yeah, correct. So my posterior mean would be what? It will be
8 by
alpha
12.
upon alpha plus beta, which is 8 by 12. You have to calculate this value. Okay. Fine. 0.6 something it will be there. Is it fine?
Yes.
The question is clear? Okay. Dipine, is the question clear to you?
Yes, yes, ma'am.
Okay, fine then. Okay, so any other questions from 10.3?
Question number 4, ma'am.
That X1. Okay. How did you, what steps did you do? Like, you must have tried it, right?
Yes,
Ma'am, question
Can I?
number 5.
Uh, just a second.
Okay.
Question number 4 or 5?
5. Gamma distribution is there.
Who asked me about 4?
Me, ma'am.
Yeah. Just let's complete question 4, then we will come back, come to 5. Yes. Question 4.
Okay, ma'am, no problem.
Yeah. Okay. So what's your doubt in question number 4? Can you just tell me? Who had the doubt for question 4?
How will you find the prior of beta?
Prior of beta. Prior is already given, right? It's just a general thing. See, it has been given that x1, x2 till xn is following IID geometric distribution with P parameter, correct? Now, the prior, this P is unknown to us. So P is following a beta distribution with alpha comma beta. This is the thing. Now you have to find out the posterior distribution. Now, posterior is proportional to likelihood into prior, right? Now, what is my likelihood? If it's a geometric. So what is the PDF of a geometric?
P
1
to the
minus
power.
pk and
We can say 1 minus P x
raised to
minus
power
1
x.
P, right?
Hmm.
Yeah?
Yes, ma'am.
So now, if I have to find out the likelihood, this will be what? Product of I going from 1 to n, 1 minus p raised to the power x minus 1 into p, correct? Now, this will be what? 1 minus p raised to the power summation of xi minus n, p raised to the power n, correct?
Yes, ma'am.
Yes, ma'am.
This is my likelihood. Now, what is my prior?
Ma'am, beta.
That is beta. So, what is the PDF of a beta distribution?
P to
Ma'am,
the power
X.
alpha minus 1
Hmm.
into 1 minus P power beta minus 1.
Correct. So this is my prior, this is my likelihood. Now put these two values into the equation. So this will be posterior is proportional to 1 minus p raised to the power summation of xi minus n p raised to the power n into p raised to the power alpha minus 1 and 1 minus p raised to the power beta minus 1. Now this will be p raised to the power n plus alpha minus 1 and 1 minus p raised to the power beta plus summation of xi minus n minus 1. Now, which distribution it is following?
Ma'am, something like beta.
Beta.
It will be beta with,
Alpha is n plus alpha.
correct,
And beta as beta plus summation of xi minus n.
correct. This is just the general formula. Got it? How to solve it? Did you get the solution?
Excuse me, ma'am.
Yes.
Can you scroll a bit up?
Up.
Yeah.
Okay.
Why did we put like summation xi and this n, like instead of 1.
Instead of 1.
Why
Okay.
did we put n?
Let's take it simple. Let's suppose my product is going from I1 to 3. Okay. 1 minus p raised to the power x minus xi minus 1. Right?
Yes.
Yeah. So now I will put the values of I here. So this will be, and this is a product. So this will be 1 minus p raised to the power x1 minus 1. Correct? Into
Yes,
1 minus p raised to the power x2 minus 1.
1.
1 minus p raised to the power x3 minus 1. Now this will be what? 1 minus p raised to the power summation of xi's?
Yes, ma'am.
x1 plus x2 plus x3. Now this will be add to minus 3.
Yes, ma'am.
Right? So I can generally write it as 1 minus p raised to the power summation of xi minus, what is my n? 3.
Yes, ma'am.
Now you got it?
Yes, ma'am.
Yeah. So is the question clear? Question 4?
Yes.
Ma'am,
Yes.
I have a doubt in last calculation after write the prior proportional to likelihood into sorry this one. Yeah, no, up to prior I understand.
Mhm.
What happened here I don't understand. Like p proportional to 1 minus p. I got it here. After that, what happened? Yeah, next line. Yes,
This
second
one?
last line.
This one?
Yes, yes,
This
this
one?
line.
I just added. See, the base is same, right? So I'm taking this p and this p. So if the bases are same, the powers will get added. So this will be n plus alpha minus
So
1.
p to the power n plus alpha minus 1.
Yeah. Now this 1 minus p,
Yes.
1 minus p. The base are same. I will add the powers. Okay. Now you got it?
What happened to beta?
Which one?
There is 1 minus p to the beta minus 1, right?
Yeah, here it is. Beta minus 1. I just put it in that way so that I can get, see, I just like.
Okay, okay. So I can get the form of beta.
Correct. I just put it in that.
Okay, okay, got it. Yeah, got it. Thank you, ma'am.
So question 4 is clear, correct? Yeah. Can I get a thumbs up?
Yes,
Or
ma'am. It's
yes
clear.
or no something? Okay. Now question 5. What's the doubt? Define.
Ma'am, gamma distribution seems like something difficult. So gamma is there.
Consider IID samples from a Poisson distribution from a Bayesian estimation of lambda using gamma parameter system. Student gamma distribution. Okay. Have you tried it?
Yes, ma'am.
Deepayan? Have you tried this question?
Ma'am, something getting difficulty in the constant. Ma'am, no, ma'am, constant not. Ma'am, in the xi part.
The likelihood part you're asking?
Yes, ma'am. And prior is constant. Ma'am, the likelihood part, ma'am, something getting missed.
Okay. So let's suppose I have x1. I'm not writing the samples. Okay. X1 and xn is following. They are IID sample from a distribution Poisson with parameter lambda. Right. This is the question. Lambda. Now this lambda is following a gamma distribution with parameter 2 comma 3. Okay. Now how are you going to solve this? First of all, I will calculate the likelihood. What is my likelihood? Okay, for a Poisson distribution, what is my PDF?
Lambda power m e power minus lambda
Minus
and
lambda x.
lambda x e power minus lambda by xi. No, ma'am. Factorial of x.
Huh?
Divided by factorial of x.
Exponential.
Please speak, like any one of you. I'm getting confused. What is the PDF of Quasha? Lambda raised to the power x, e raised to the power
minus lambda by
That's it.
factorial of x.
By factorial of x. So this is my PDF. Okay. Now the first, what is likelihood? Likelihood is the product. Correct. I go from 1 to n. E raised to the power minus lambda, lambda raised to the power x upon factorial x. Correct. Now, if I'm taking the product, so this will be what? E raised to the power minus
We will sum up.
n lambda, lambda raised to the power summation of xi divided by this will be the product of factorial x. Correct. Let's take it simple. I'm taking product, I going from 1 to 3. Okay. E raised to the power minus lambda, lambda raised to the power x upon factorial x. Now, for I equals to 1, so this will be e raised to the power minus lambda, lambda raised to the power x1 upon factorial x1 into e raised to the power minus lambda, lambda raised to the power x2 upon factorial x2 into e raised to the power minus lambda, lambda raised to the power x3 upon factorial x3. Correct? Now, if I do it like if I multiply whole this, so e raised to the power minus lambda, so this will be like 3 lambda.
Yes, ma'am.
Yes or no? Yeah. Now, this will be lambda raised to the power x1 plus x2 plus x3. I can write it as summation of xi upon.
Yes, ma'am.
Now, factorial x1 is multiplied by factorial x2. So, I can write this as multiplication of factorial xi.
Yes, ma'am.
So, similarly, so if my I is going from 1 to n, this will be e raised to the power minus n lambda, lambda raised to the power summation of xi upon product of factorial xi. Is this fine?
Yes, ma'am.
Okay. Now you got the likelihood. Now the rest of it, can you solve it? What will be my prior?
Yes, ma'am. Gamma distribution.
Yeah. What is the gamma distribution? Tell me the PDF. Tell me. Anyone?
E to the minus 3 lambda and e to the minus 4 lambda. So it gets e to the minus, here it should be e to the minus n plus 1 lambda and lambda to the power 1 plus summation over xi by x factorial plus
No, just a second. I'm just asking the prior, like for the gamma prior distribution.
Okay,
X to the power alpha minus 1, e to the power minus beta x.
So this will be e raised to the power minus 3 lambda, lambda raised to the power
Alpha minus 1.
alpha minus 1. So this will be 1 only.
Yes. Alpha
Ma'am,
minus
can you elaborate these steps?
Okay. So my prior for a gamma distribution. For a gamma distribution, alpha comma beta, my PDF would be lambda raised to, let's take x raised to the power alpha minus 1, e raised to the power minus beta x. This is my PDF. So just compare this equation with this. So this will be what? E raised to the power beta is, this is my beta. And this is alpha minus 1. So this is minus beta lambda and alpha is 2. So it will be 2 minus 1, which is 1. Is this fine?
Yes, ma'am.
Yeah. So I've got the likelihood. I have got the prior. Now you just have to put it. So my posterior distribution will be proportional to e raised to the power. Now this thing, I'll just take this out because this is like just act like a constant term because it is not depending upon my lambda. So I will be taking out this value only. So it will be e raised to the power minus n lambda, lambda raised to the power summation of xi into e raised to the power minus 3 lambda, lambda raised to the power 1. Is it fine?
Yes, ma'am.
Yes, ma'am.
Okay. Now you just have to put this value summation of xi. You have been given the samples 2, 3, 4, 2. that sample, right? So you have to add this. So you will be getting e raised to the power minus lambda 3 plus n into lambda raised to the power summation of xi plus 1. So this is the thing. So you have to add it, you have to put the values and solve. Is it fine?
Okay, ma'am. Understood.
Understood? Good. What about others? Is it fine? Is the question clear to you?
No, ma'am. Actually, answer is not coming even after this. Would you please?
Answer is not coming. What about others? Are you getting the answer? Anyone getting the answer?
Yes, ma'am.
The answer is not same.
Ma'am, I have used the formula directly which is given in the lecture, which is summation of the samples plus the alpha and divided by the number of samples plus beta, then I'm directly getting the answer.
Okay. How many samples are there?
10 samples are there.
10 lambda raised to the power and summation of xi. What is the sum?
It's 25.
It's 25. So 25 plus 1. Now this is following my gamma distribution with parameters. So this is my beta. So this will be 25, 26 plus 1.
So in the denominator, there would be this multiplication of this xi factorials, right?
Sorry, what?
In the denominator, you will have this multiplication of xi factorials, right?
Correct. Yeah.
Yeah, but that would be a constant, so we can contract into the proportionality. That's fine. Yeah.
Correct. So now I have to calculate the posterior mean. So this will be 27 by 30. What is the answer?
30. 2.07.
2.07. Is this the answer?
Oh no, ma'am. I was thinking of the next question. I was sorry. Sorry. No, this was okay.
Okay then. So question 5th is clear.
Yes, ma'am.
Yes, ma'am.
Okay. So 10 point. Any other doubts? Only 6 question is left. So you have doubts in question 6. Anyone? No.
Ma'am, the sixth question, the first part is that gamma n plus 1 is coming, but that summation is not coming. That is something not coming. Actually, that is how I marked the first one. It happened to be correct, but I could not find the beta of that.
Let x1 be an NIID samples from an exponential distribution. Okay. So this will be my x1, x2, xn is following exponential with parameter lambda. Okay. What is the PDF of exponential? Lambda e raised to the power minus lambda x.
Minus lambda x.
Now, what will be my likelihood? Now you tell me the process.
Lambda,
Likelihood will be
lambda to the power n e power minus lambda summation of xi.
What will be my prior?
What was the prior?
Gamma,
One.
right?
Oh.
1. Is the prior 1?
1.
Yes,
Yes,
because in question they're asking uniformly 0.
Yes. Okay. So till here, this calculation is fine to you. The person who asked me the doubt, who's asking me the doubt. Okay.
Yes,
then. Okay. Then posterior will be lambda raised to the power n e raised to the power lambda summation of xi, right?
Yes.
Okay. So now this is following a gamma. Now lambda raised to this. So this is my alpha minus 1.
Yes.
So this will be n plus 1. Now this will be my beta.
Beta won't be lambda into sigma x1, or it would be just x1.
For gamma, what is it? X raised to the power alpha minus 1, e raised to the power minus beta x,
Beta
right?
x.
Right.
So if you compare it with this, lambda raised to the power n, e raised to the power minus lambda summation of xi. So summation
So
of xi will be my beta.
instead of x, it is lambda.
Oh, okay, okay. Thank you.
Now
That
you
was
got the point.
that is the confusion. Yes.
So this will be, sorry, this will be alpha beta x. So instead of x, I have lambda.
Oh,
Got it?
no, yes, got it.
So 10.3 is clear?
Yes, madam.
Okay. So let's move forward to 10.4. Any doubts in 10.4?
Yes, ma'am. All the questions, actually, the concept itself that in the lectures they have shown about some turtles or something. Similar concept is in tigers. What was it? Turtles. In question number 1, is it that we are calculating that 15% of, I mean, 30 are captured and released, then 15 are found to be marked out of 50. That means 30% are found marked. So 30% is 30. So you calculate the
It's just a simple, no, it's just, what's the
unitary method. Is it like that?
No,
Ma'am,
this
can you
is
explain the concept of Week-4, please?
to find an estimate of the number of olives nesting in a town along the road. You capture 30 turtles and mark them. A week later, again, you capture 50 of them and 15 are found to be marked. Estimate the size of the population.
So
This is a hypergeometric case.
Okay. Would you please solve one question and explain this? I won't ask many. First,
Let me just see it. Just wait a second. Okay. So the question is to find an estimate of the number of olive nightly turtles nesting in town along the east coast of India. Capture 30 olive turtles and mark them. So let's suppose I'm having n population size. Okay. So if I'm having n population size, from that 30 are marked. Okay. Now, a week later, again you capture. Okay. So if 30 are marked and how many are there who have not been marked? It will be n minus 30 unmarked. These are my unmarked. Now, what they are saying, a week later, again you capture 50 of them and 15 are found to be marked. So I am picking out, like from this, I'm randomly picking 50 of them. Okay. From this 50, I have like 15 of them are marked. Okay. Now the question is, what is the estimate the size of the population? Okay.
Ma'am,
Yes.
ma'am, what is the mean by marked? Ma'am, something like, ma'am, they are labeled the turtles, or ma'am, give them some identity like ships.
Once again, what?
Ma'am, what is the meaning of marked in this question?
Marked in the sense they like they have been tagged or something. Like in general, like if you see like like in north, I don't know about the south case, but in north, like the cows, they are tagged, like the government tag is there on every cows. Like, have you
Mm,
seen like
yes, ma'am.
the
Yes,
yellow
ma'am.
tag? Yeah,
Yes,
like that.
yes. Yellow tag on their ears.
Yeah, correct. So like that, so it's the same thing. So the turtles have been marked. So from the N population, I have 30 turtles who have been marked and N minus 30 who have been unmarked. Now I have taken a sample of 30 from which 15 have been marked. Okay. Now the question they are asking is, what is the population size? Now 15 have been marked. So what is the probability that the that uh, let's suppose X is my the number of marked turtles. Okay. Now, what is the probability that my X is 15? It will be from this 30, I am taking 15, right? Because from the marked only, I can take only 15 of them, right?
Yes,
Yes
ma'am.
or no? Okay. Now the remaining, okay. So I have a sample of 15. So I have a sample of 50. So from that 15 are being marked. So how many are left who are not marked?
35.
20.
20.
20.
It will be 35.
Oh, 20.
Okay. Yes or no? Now, and the total will be n by 50. This is from n, we are choosing a sample, and in that sample, from the 30, I have a 15 who have been marked, and from the remaining of them untagged, unmarked, we are taking 35. Is this fine?
Yes, ma'am.
Sure, everyone? Can I get a thumbs up or something? Or do you want me to repeat?
Yes, ma'am, it's clear.
It's clear? Okay. Now, so we are just taking I have like I took like we are taking one sample from it. Okay, so if you are taking one sample from it, my sample mean would be only one sample. So what will be my sample?
And something like 50. Yeah,
50.
15.
It will be 15. Okay. Now, and if you remember the method of movements, okay, if method of movements, that my sample mean, which is will be equal to what? This mean this sorry, this is the we have not calculated this. Expectation would be what?
Mu.
It will be we are taking 50, right? So 50 into 30 divided by n. Correct.
Yes, this is
For a
from
high
this is from where it is coming. This is in the lecture. But from where is this 50 into 30 coming? Would you please
for a
explain?
high for a hypergeometric, what is the formula for of expectation? It is n into k divided by n. This is my formula, right? M into k. This would be m into, yeah, n into k divided by n. Do you remember this thing?
Okay, no. What was n was what? N was the bigger population.
And capital N is the population size, right? And small n is like for what?
Yeah, sample size. Yeah,
Ah,
and
now
k
you
is
remember.
what? K is what?
K is like the like from that. See the 30
Oh,
आपने
oh,
marks.
I got it.
Now
Means
you got it.
yes, yes, yes.
Hmm.
Hmm.
So yeah, so this is my expectation and this is my sample mean. So according to method of movements, my sample mean would be equal to the this expectation, correct? Yes or no?
Yes, ma'am.
Right? So now this will be equal, sample mean is 15 equals to 50 into 30 divided by n. Now I have to calculate this value of n. So n will be 50 into 30 divided by 15. So this will be equal to what?
100.
Now you got the,
Yes, ma'am. Even if we don't use such long formulas, if we use the unitary method, also it works. Why so? Means if I say that in this question, what you say, 15 have been found to be marked. That means 30% are found to be marked. So what is if 30% is 15, then then find the size of the population. You will get it. Means 30% are marked. So what is the full population? Population is 100. So why is these two clashing? Means why is this also coming in to the same result, and the school boy type of means school assumption that a unitary method that also works?
how you are using unitary, can you just explain it to me?
Ma'am, yes, I am telling you. To find an estimate of the number of live deadly turtles and East Coast, you capture 30 turtles. Okay, you capture 30 turtles. Okay,
Hmm.
and so out of after a week, 50 turtles are what? You have taken 50 turtles, out of which 15 has been found to be marked. So 15 by 50 x 15 by 50, that is 3 by 10 of the population is marked. A 3 by 10 of the population is marked, which is 30. So x is equal to 300 by 3, which is 100.
This is the point, right? So from the 50 samples, I'm getting 15 as mark. So now
Yes.
they are saying that from the acha, okay. Okay, you're doing it like that. So like from the 50, I'm getting 15. So okay, let's take it like 15 like this. So if I'm getting 30, so this will be 50 by 15 into 30, right?
Yes.
This will be 100.
Yes.
Okay.
This is like class 7 8 maths,
Unitary method.
but how are we actually having the same answer in such different scenarios?
To find an estimate.
Means will it work in my exams, or where am I going wrong?
Dekho, listen. So what we are doing, this so that that can't be I don't think so. Like that method, okay, you got the answer, that is fine. But here we are taking a sample, right? We are taking 50 of them, and from that 15 are to be marked.
Yes.
So like, see, the thing is, in this question, there is one population, and from that population, we have 30 of them are marked and n minus 30 are of them are unmarked. Okay. Now, we are taking a sample. What is my sample? My sample is like 50, like I'm taking a sample of 50. From that 50, I have 15 of them as marked. Now, if I have to calculate probability of X, okay, so what is my hypergeometry? Do you know what is my hypergeometry? Let's suppose,
Yes.
like, if I have total of n objects, and from these n objects, I am taking, like, I am selecting n,
Yes.
like n objects I am selecting. Okay, from that, from this n, I have m of one type and
N of
and the
another.
I have
N
n
minus
minus m.
M of other type or something. Hello.
sorry, what?
Yeah, N minus M of some other type.
I have, so m is of one type and n minus m is of another type. Correct? This will be m, and this will be n minus m. Okay. Now, so if I'm so from this sample only I'm sorry, from this population only I'm taking a sample in which I have m of one type and n minus. Similarly, so I have a population, from this 30 have been marked and the rest of them are unmarked. Okay. Now from this I'm taking a sample of 50. From this sample, I have got the answer like 15 of them are marked. So what is the probability that 15 have been marked? So this will be what? So 15 of them marked. So I am taking, if 15 are marked, so I will be taking from here.
Yes.
Correct? So from 30, I will be choosing 15. Then n, from n minus 30, I will be choosing the rest of the animals divided by n 50.
Yes.
Okay. So this is a different condition. That is a different condition that you are solving.
Yes.
Now you got the point?
Yes. But in two cases, the answers matched. So that's why I thought.
Oh, it's fine.
Yes.
Okay. Vicky, you have raised your hands. Vicky, what's your doubt? Is he here? Are you able to? Okay, then I think he's here. Okay, then. So this, what was the question? So 10.4. So question 1 is clear?
None here. Sample mean how you got 15.
Sample me. Okay. So just in general, if I take, so let's suppose, like, in general, we have a samples like 1 comma 1 comma 0 comma 0, like something like that. So if we take a sample, if we take the mean, it's just we are summing all the values and dividing it by the number of terms. Correct? So if I, let's suppose, if I'm taking 1 comma uh, 1 comma 2 comma something, like 1 comma 2, if I'm taking only two samples, right? If I'm taking 2, so this will be what? What will be my average?
Three by 2.
In the sense, if I'm having only 1 comma 1, if I'm only having this, so this will be what? 2 by 2, which will be 1. Correct? So if I'm having all the samples, like I am taking, so if the sample, so from this 50, I have 15 of them as marked. So I'm taking a sample in which the number of the thing is, we are taking the expectation of the marked turtles, right? So what is the sample mean of the marked turtles? It will be 15 only. All of them are marked. 1 comma, like, all of them are marked. 15 of them. So my sample mean would be 15 only. You getting the point? All of them are 1, 1, 1. So if we are taking a sample, so there are like one is considering that the turtle has been marked, and 0 is being considered as the turtle are unmarked. So we are taking the sample mean for the one who have been marked. So all of them are 1, 1, 1 like that. So if I have like that, so what will be my sample mean? Sample mean would be my 15. You getting the point?
Ma'am, 111 15 times.
15, So just a second. Uh, mm, 7. Just a second. I'm not able to how do I put it? It's like अपनी ये capture करते थे ना I'm not able to put it, but anybody got the idea? How can I put it? I'm not able to put it. Anybody having any idea? I'll just clear that doubt in the next session, can I? Or I just need time to think. Is it fine to think? Is
Okay,
it
ma'am.
fine?
Okay,
Yeah.
ma'am.
Okay. Okay. So 10.4, any other doubts?
Ma'am, question number 4. Ma'am, how to, ma'am, some steps to perform that question.
Question number 4. Let P represent the proportion of defective items Suppose that 10 items are sampled from a production line and 3 are to be defective. Use beta prior to estimate the unknown proportion P. Defective, write your answer. It's just simple. Like, so they are saying that from the 10, like I have a population, let's suppose I'm having n as 10. From that, the number of, what was it? 3 are found to be defective. So the number of defective are 3.
3.
And undefective will be
7.
7, right? So if you remember, if my x1, x2, xn are IIT samples, which is following a Bernoulli with p as a parameter, right? So what is a Bernoulli? Bernoulli is like I have a success and I have a failure, correct? Right? Similarly,
Something
so
like,
what is,
ma'am, something
sorry?
like true and false line. Ma'am,
True and false. So according to this question, my success is being defective, getting defective item, and my failure will be getting
undefective.
Okay. So this is the thing. So now, according to the question, my prior is following
Beta 0.05.
beta 0.5, 0.5 and 0.5. Now, my likelihood will be what? P raised to the power?
P cube and 1 minus P to the power 3. 1 minus P to the power 7.
7. Okay. And my prior. So my posterior distribution will be P raised to the power 3, 1 minus P raised to the power 7 into
prior.
P raised to the power 0.5.
0.5 and e to the minus beta half.
Ma'am, minus 0. Ma'am, both.
Okay. Now this will be 3 minus 0.5. It will be
P 2.5 and 1 minus P 6.5.
6.5. Now this is beta with
3.5 and 7.5.
That's it. Got it?
Understood, ma'am.
Okay. Any other question? From 10.4? Any other question from 10.4? No?
Ma'am, in question number 6, ma'am, there is a word written, ma'am, prior belief. Ma'am, that.
Question number 6. The number of call answered by a phone center during the number of call answered are we over a 10 period are this from the previous record. One believes the prior distribution has mean and this use a gamma prior that matches the prior belief and find its posterior. Yeah. So you are asking about
Prior belief, ma'am. What is that, ma'am? What, ma'am? How to interpret that, ma'am?
Prior belief, that means they are they are saying that from the prior distribution, like prior distribution of lambda, they have mean 4 and standard deviation 1. So we are taking a prior distribution as alpha gamma, following a distribution gamma with
Alpha,
parameters
beta.
alpha and beta, and this gamma distribution are having a mean 4 and standard deviation 1 according to the prior belief. Okay. That is the statement. Fine.
Yes, ma'am. Ma'am, that remaining will be same, na? That Poisson, ma'am, and multiplication of all factorial.
What?
Ma'am, rest of the process will be same.
Same. From like the first process is you have to calculate the value of alpha and beta from the mean and standard deviation. Then the rest of the process is same. You have all the Poisson, then you have to put all the values of gamma, prior and all, and solve it. Fine?
Understood, ma'am.
Okay. Vicky, you have raised your hand. Are you here?
Yes, ma'am. Ma'am, can
Yeah.
you go to the
Okay.
last question which you have solved from the 10.4?
Last question.
Yeah, the last question which you did now, that 13 to 50. That 50, like 15, this sample mean, how you like how we get it, ma'am?
Yeah, that
This
is, I'm not able to put it. I'll just think about it. Like, I'm not getting how to like
how you
explain it.
got this sample mean, ma'am, 15?
Yeah, that is one. So I'm not able to explain it. I just need some
Okay.
time. I'm just thinking about it. I'll
Okay.
just explain it.
Okay.
Yeah.
Not a problem. Not a problem.
Yeah. Yeah. Oh, okay. Okay. Till then, any other doubt in from 10.4? No doubts. Okay. Let's go to the practice assignment then. Any doubts from the practice assignment? Anyone?
I'm not yet solved. Today, like night, we will solve.
Tomorrow is the deadline for the graded assignment, right?
Yes, ma'am.
This assignment. Okay, nobody has solved the questions from the practice assignment.
Ma'am, tutorial to question number 5.
Tutorial two. Question number 5. That be the proportion. Maybe the proportion of people who like the product text equals to consider the samples. From the data collected regarding the average of the proportion of people who like the product is 60%. Average of the proportion. Okay. Use a beta alpha comma 4 with a suitable alpha to estimate the proportion. Okay. So first of all, it's the same question that we did, right? So we have been given the samples. We have the prior information that my P is following a beta alpha comma 4, and the average is also given, which is 60%. It's the same
Ma'am,
question.
I am asking how this 60% is expectation of prior.
Expectation of prior.
Prior. Yes, ma'am.
Okay, so the average they are showing is 60%. What is this average? This is the average of the proportion of people who liked the product, right? And what is what is my P? P is the proportion of people who like the product, and the average of that proportion of people who like the product is 60%. And this P is following a distribution which is beta alpha comma 4, right? So this the you getting my point? P is following a beta alpha comma 4, and
So, ma'am, prior is the distribution of probability.
sorry, what?
Prior is the distribution of probability, na? You said P follows this beta alpha comma 4.
See. First of all, I have a sample x1, x2, something till xn, okay, which is let's suppose which is following a Bernoulli with p as a parameter. Now this p, what is my p? This is the proportion of people who liked the product, correct? This is my p. Now this p is following a beta distribution with alpha comma beta as a parameter. And the thing that it is given that the average of proportion of people who like the product is 60%. Now the proportion. So they're talking about P only, right? So now this P is following beta, alpha, comma, beta, and the product, sorry, the average of P, that is the expectation of P is coming out to be 0.6.
Okay, ma'am, I was asking this distribution prior, what prior is? Prior is the distribution of probability, na? This is what I'm asking.
Which probability?
No, ma'am, probability. I'm saying
Parameter.
P is the probability, na?
P is not a probability. P is a parameter.
P is a parameter.
Okay, P is a parameter. Portion.
Like
Okay,
if
and proportion is following this.
okay, now is it clear?
But ma'am, when we write Bernoulli P, so their P is probability, na? Probability of success.
That is a probability of
This is a
success, but
probability of
it is
success,
not known to
but it
us.
is not
Now,
known.
according to Bayesian estimation, this P is following some, this P is a random variable which is following some distribution. Like my x1, x2, these are my random variable which is following some distribution. Similarly, my P is following some distribution which is beta. Okay, so this is, right now, this is not a probability. This is a parameter. We are estimating the parameter. Okay.
Okay. So we are trying to estimate the probability, matlab probability of success, na, ultimately.
We we can say that. Yeah, we can say.
We can say that, na, ma'am.
Yes. Okay.
Okay, ma'am, understood.
Okay. Anything else? Any other doubts?
Ma'am, if week 10 is over, then week 9 I had a small doubt.
Week 9.
Yes, ma'am.
Week 9. What's your doubt?
Just a second. Let me open the week 9.
So week 10 is clear to everyone. There are no doubts. The people who have solved the assignments and everything, activity questions.
Ma'am, I have a doubt in practice assignment.
Next question.
Which question?
Ma'am, number 5 question.
The new method of screening for a disease fails to detect the presence of disease. Prior experience and random variable sample of 10 people should one know to have the difference between using the medical out of these 100 patients. The method will be detected in this insulin also they will be tested with infection ingredients. The new method of screening fails to detect the current variable of 20% of the patients from prior experience. This is in 20 cases. Have you tried this question? What's your step? Which how did you started the question? Like I'm asking you. Hello.
Yes, ma'am.
Yeah. So how did you
So how did you
calculated the value?
calculate the value?
Like some approach,
Some
what approach
approach,
did you
what
use?
approach did you use? Mm, and here this 20% is expectation.
Huh, correct.
Expectation of prior, na?
Huh. Now,
Now. Ma'am, that point, what is over out of 100%, the new method failed to detect the disease of 20 cases. This is what I'm not getting well.
so that is like a simple
That
Bernoulli,
is
right?
a
So if
simple
I'm having
Bernoulli,
a
right?
sample,
If I'm having a
like
sample,
I'm having 100 samples, from that 100 samples, I have 20 cases in which the new method failed to detect the disease, right? It's just a Bernoulli case. So what is the probability that they are not able to detect the disease? It is 0.2, that is 20 by 100. Yes or no?
yes or no? Yes, ma'am, 20 by 100.
Ah,
Ah,
so that is what.
so that is what. So, ma'am, how do we calculate this? Not from this 20%, this is the expectation. So here we can calculate beta. Understood, but
You understood? Same thing. I'm having X1, X2, I'm having 100 samples, which is following Bernoulli with P as a parameter. Now this P is unknown to us. Now P is following a beta distribution with parameter. What is the value? 2 comma beta, correct? 2 comma beta. And they're saying that the expectation, like the new method of screening for a disease fails to detect the presence of the disease in 20% of the patients from the prior experience. That means my expected value is coming out to be 20%, which is 0.2. Now, so the expected, this prior expectation have been given. We have been given the distribution that it is following. So we need to calculate the beta. After calculating the beta, this is my likelihood. What will be my likelihood? It will be p raised to the power 20 and 1 minus p raised to the power 80. This is my likelihood.
this is my
So,
likelihood. Okay.
so and p alpha minus 1, 1 minus p beta minus 1. This is my prior. Now you got the point?
Yes, ma'am. Okay, and from this we get the distribution of posterior density, and from that, okay, ma'am, understood.
Understood? Anything else?
Ma'am, week 9, activity 6, question 2, and activity 7, question 3, they seem to be contradicting each other.
Can you repeat activity 6?
Question 2 and activity 7, question 3 is kind of contradicting each other. I cannot make sense how it is.
Just a second. I'll just look into it. Question number 2, right? Let x is following. Consider this find the maximum likelihood estimate of n. Maximum likelihood. Sure. Um, 7. From 7, which question? 3.
3.
Please find the maximum likelihood estimator of A for the sampling X1 plus. X is for the uniform one. X is for the from see activity 7, it is a X is following a uniform A comma B. This is a
Continuous one, and
continuous,
that
is a discrete. Correct. So if it's a discrete, X is following this. Consider a sampling from the distribution. Find the maximum likelihood estimator.
First of all, I could not do it anyhow. I just understood that somehow I have to pick out the maximum and put it. But again, in the second case, I had to pick out the minimum. I am not clear with it, with these two questions. Contradictory. Even if you differentiate or what you do, it is like 12 n to the power minus 12. It is going all over the place.
Considering a sum. So maximum likelihood, so we have to take likelihood this will be 1 by n. So this 1 by n will go raised to 1. So that I guess we have to 1 by n. Initiated by work. Let me try it. Just a second. So X is following a uniform with 1 comma 2 till n, right? Okay. So for one, let's suppose for what is the probability of each of the values? It will be 1 by n. For
Yes,
2, it will be 1 by n, like that, right? Now I have to find out the likelihood first. What is my likelihood? Likelihood will be the product of I going from 1 to n and the probability 1 by n, correct?
Yes.
1 by this will be 1 by n. Now, so this will be 1 by n. So for each of the product, this will be 1 by n raised to the power n. If I take log of L will be n log 1 by n. So just a second, 1 by n. This is with an consider a silicon.
N turns out to be 1 by E here.
Sorry, what?
If you compute the maximize the function, N turns out to be 1 by E.
One.
How?
This is not.
Okay. So this can be written as minus n log n, right? This is What is k?
What is it? Okay, fine.
And this is just minus n log n, right?
So n
So
will
then
be
you
k
can
cancelled. So we will
yes,
be
yes. So
taking on p.
what you will get is log n equals minus 1. Since I
Correct.
mean log here is actually ln, right? So ln n equals minus 1. So that if you take, so I mean if you take, so log n by log e actually. So equals to minus 1. So log n equals to minus log e. So n equals e to the minus 1 if you just compare the
Yeah,
arguments.
but the thing is, we are finding in MLE, we are taking out maximum likelihood estimate, right? So after this, after differentiating log L with respect to some parameter, we put it equal to 0, correct? Then we calculate, like we equate this value and we calculate the value of the parameter, right? Now in this, my parameter is already getting cancelled, right?
Yes.
My parameter, my n, it is already getting cancelled. Yes or no?
Yes. Then.
Yeah. So the basic. So what is my maximum
Ma'am,
likelihood? Maximum
ma'am,
likelihood
ma'am,
is
ma'am,
basically
ma'am,
max.
please differentiate that n log minus n log n so that I get it.
Okay.
What was it happening?
Okay. So first of all, my n likelihood will be what? One. If my summation is going, let's suppose my this is n. So my I is going from 1 to k. Let's suppose,
Mm.
or let's take it n only. Okay. And the probability for each of the values 1 by n, right?
Mm.
So sorry, this is the product.
This is a product.
Okay, now this will be 1 by n raised to the power n only. Now the next step is I will be taking log, which will be 1 n into log of 1 by n, correct?
Yes.
Now the next step is we will be differentiating with respect to n,
Mm.
right? Now this
So
will be
it
what?
can be written as minus n log n. Yeah. N. Because 1
Because
by
log
n
n
is.
is yeah, it's log a by b, right? It's log a minus log.
So it is a multiplication rule which is equal to minus log n. That is the one thing, and and the second one is uh, uh, 1 by n. What are you doing? Log. Uh, no, I'll differentiate. I'm differentiating.
You just use the quotient rule, right? Log of a by b equals log a minus
No,
log
no,
b.
this is a product rule, not a quotient rule, because it is n into log n. That is that is the function. So it is n log n. So n gets differentiated first. So this is minus log n plus minus n by n. That is minus 1. So it is minus log n minus 1. It is not getting cancelled.
See, we will be taking like my likelihood will be the product of my I is going from 1 to k. We won't be taking n, we will be taking k, like k values. And each of the probabilities, each of the values are having a probability of 1 by n, correct?
Okay.
We won't be taking n, we will be taking some other value which is k. I is going from 1 to k. Fine?
Okay. Okay.
Okay. Now, so this will be 1 by k, 1 by n raised to the power k,
Yes.
right?
Yes.
Okay. Now, this k is basically what? According to the sample, this k is 13, right? We have been given 13 samples.
Yes.
True?
13. 13. Yes.
13 samples, right? So this k is actually my 13. Now, if I differentiate this value, k is a constant term, we won't be differentiating that. So log of 1 by k, this is, I will be having n
Yes.
minus n square, right?
Yes.
1 by n. Huh.
1 by. Ma'am, even if we did not take the log also, then also we could have easily differentiated. N to the power minus k. It was quite easily differentiated.
N to the power minus k.
Yes, it is simple.
No, these are the steps, right? First of all, you have to take the log, then you have to differentiate
No,
it.
we take log so that log makes the calculations easier. But we could have differentiated the original function also. Same thing. Anyway, we take the log.
Huh, like, okay, if you take like this also and then differentiate it, this will be what? N raised to the power minus k plus 1 upon k plus 1, right?
Yes, that is just n raised to
That's
the
like the
power.
differential. So this will be minus k minus 1. Now you will put this value equals to 0. So this will be what? N raised to the power minus k minus 1 equals to 0.
One quick question here. So shouldn't our PMF also be 1 over k because we are taking home? So why you are taking like I equals to 1 to k instead of 1 to n?
Because see, this is just a uniform. Like this is a uniform. My samples, my values are taking a uniform distribution from 1 to n. And how many samples I'm having x1, x2 till
Oh, you're having
x13.
13 samples. Okay, okay.
Okay, so I will be I will be doing the product for 1 to k, which is 1 to 13. Okay, then I will be taking the log, then I will be having this value. This will be equal to minus k by n. Now minus k by n is equals to 0. So
Now somewhere here I stopped. Both without log function or with function. Both have stopped here. Now what do we do?
so like yeah, from here only we can say that I'm not getting the parameter. I'm not able to estimate the values, estimate the value of n, right? So we would be taking the maximum of the uh, uh, we will be taking the maximum of the samples. As
Okay.
from this, we are not able to calculate we are not able to estimate the uh, value of n. So we will be taking the maximum of the samples, which is xi. So if I take the
The
maximum of
maximum,
these,
then 1 by n becomes the minimum. Is that the logic?
sorry, what
If n is maximum, 1 by n of that will be
will
minimum
be the
in the
minimum?
set. Yeah, so that is the logic behind it. And then what is the logic for the seventh activity 7 and question number 3?
Activity 7, access following. Okay, so x is following uniform a comma b, right? This is the value, and find the maximum likelihood estimator away for the samples. Okay, now if my x is following uniform, so my fx would be what? This will be 1 upon b minus a, and the values the values of, let's suppose my x is going from a to b, correct? This is my parameter.
Yes.
Now I'm having samples like x1, x2, x3, so on like that, correct? I'm having xn samples. So if I calculate if I calculate the likelihood, right? This will be the product of 1 by b minus a. My I is going from 1 to n, correct? Now the intervals will be from x1, x2, xn, like this,
Yes.
right? Now they are saying find the maximum likelihood estimate of a. So what will be my maximum likelihood estimate of a according to this? So for a, what will be my maximum likelihood? This one.
I'm not getting this. How?
Not this one, basically. So my maximum likelihood of a would be my minimum of x1, x2, xn. which is basically what? If you see here, my x1 is the minimum, so my x1 will be the maximum likelihood estimate. So we will be taking like like from A, which is the maximum value. Okay.
No, this one I'm not clear. How will I take the minimum? Why will I take the minimum? I'm not clear. And this one I'm not out.
Um, for the okay, so when we are calculating the maximum likelihood, do you remember that when we double differentiate, the value should like it should be less than zero, like it should be.
Yes, 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 yes. So that is a maximum.
So that is like my maximum. So here only, if I'm asking like what is the maximum likelihood estimate of A, so and my values of like my interval is going from A to B. So from here, so I will be taking the value of let's take it to the next class. Actually, I'm not able to remember the concept. I'll just come back with this in the next session. Can I?
Okay, no problem. Thank you.
Yeah.
Thank you.
Okay. I'm so sorry about it, but I need to recap all the points again. Okay.
Yes, ma'am. One another
Yes,
doubt.
ma'am. One another.
Doubt. Hello.
Yeah, yeah. What's your doubt?
Though it is in week 9, I am a bit lagged behind because of something. Just a bit.
What is it?
Tutorial 2, week 9, fifth question. No, not fifth question, sixth question actually. It's a continuation of the fifth.
Tutorial 2 question.
Question sixth. It is a continuation of the fifth question.
Sixth. Just a second. Probability density function is given by this, where this be that by right, and the maximum estimate of sigma. The expected value is this one, is using method of bonus. Sixth. Okay. So method of movements, basically you have been given the population, like you have been given the expected value of the PDF, right? Which is sigma under root. Now this will be equal to what? The sample mean, which is 3, 5, 7, 4. So you would be calculating the value of sample mean and you will be putting it equal to the sigma under root pi by 2. This is how, that is how you do the method of movements, right?
Yes, ma'am. But here the series that I have got is a series of multiplication of e with a very square. I don't know how to do it. That is
Yeah, but that you don't have to calculate, right? It is already given that the mean of that PDF is coming out to be e raised to the sorry, sigma into under root pi by 2. So you don't have to calculate it. You just have to put it equal to the sample mean.
please explain that. Just please.
Acha, okay. They have been given like they have given us one PDF which is fx x by sigma square e raised to the power minus x square upon 2 sigma square. This is the, and their expect that the mean is given, that is expected value is given to be sigma under root pi by 2, right? Now, if you know the method of movements, what is method of movements? We are keeping this expected value equal to the sample mean, correct? Yes or no?
Yes.
This is how we do it, right? So this expected value is sigma under root pi by 2. And what is my sample mean? Sample mean is 3 plus 5 plus 7 plus 4 divided by 4. Correct?
Oh,
For
not putting that into the x values. What I had done was I had put x into that equation and then I had
no. That is a different thing, right?
okay.
This what is
This
my
is not
f1? This is my sample mean.
okay.
Okay.
Okay. Okay. Okay. So now what I will solve for, I will solve for sigma.
For sigma, yeah.
Okay.
Okay. So
Yeah.
this is
Thanks.
okay. Anything else?
Ma'am, ma'am, can I ask doubt of quiz 2?
Quiz 2. Okay. What's
Yes,
the doubt?
ma'am.
Okay. What's your doubt?
Uh, Ma'am, this question, let L xy uniform D where D is equal to xy x square plus y square less than 4, x greater than 0, y greater than 0. What is the marginal density function of fx?
Um, okay. What's your doubt with that?
Actually, I nah, actually I got the answer that answer, ma'am.
No.
Under root 4 minus x square by 4 pi I got. Is this wrong?
If I remember the question correctly, the question was d is x square plus y square less than equal to 4. Correct? This is the equation.
Yes,
And
ma'am.
x is
And
greater than
xy
0,
both are
1
greater
is
than
greater than
0.
0.
Yes, ma'am.
So now, if you draw the graph, this is this equation, this x square plus y square equals to r square. This is the equation of a circle, correct? Now, here it is given that x square plus y square is less than equal to 4 and my value of x is greater than 0 and y is greater than 0. That means this will come under only first quadrant, right?
Yes, ma'am.
Okay. Now, this will be what? This will be 2 because this is r square. R square that means 2 square, correct?
Oh, yes, ma'am.
My
2 square.
radius will be 2. My radius will be 2. Now, you are asking about the PDF, right? FXY,
Yes, ma'am. PDF.
the PDF. The PDF would be what? 1 by mod of D.
Yes,
This
ma'am.
is what?
Mod of D.
Now, what is D? D is what? My what is the area of a circle?
Area will be 4 pi. Total
Area will
area
be
will be 4
no.
pi.
I'm just asking what is the area of a circle?
Pi r square.
Pi r square. Okay. Now I'm just taking the first quarter. So I will be dividing this by 2.
Yes, ma'am.
Okay. Now, if I calculate the value pi into what is r square? 4.
What, ma'am?
What is the value of r square?
R square is 4.
Divided by 4. So this is pi. So my value of d is coming out to be pi. Is this fine?
Ma'am, what is the value of D? Your sound is not coming well. What is the value of D?
The value of d will be pi.
Pi 4 pi divided by 4. है ना?
Not share the screen. Now is it fine?
Yes, ma'am.
Okay. So the value of d is pi. So what will be my PDF? It will be 1 by d mod, which is 1 by pi. Fine?
Yes, ma'am.
This was it out?
Yeah, actually, there I was doing. Ma- actually, mistakenly, I took 4 as the radius. That's why I got confused.
Okay, that's fine. Okay. Now is it fine? Is there anything else?
Hmm. Ma'am, the probability there y less than 1, x less than 1, and y less than 1, that will be this now of 3 pi, na?
What? Come again?
Ma'am, that question, probability of x less than 1, y less than 1.
X less than 1, like y less than 1.